Hey, so we've been talking about the law of cosines in class, and it can be pretty confusing. The formula for the law of cosines looks like this. It can take three different forms, but generally it looks like this. There we go. Okay. So what is this saying? C squared. Well, if we look in our diagram here, what is it we're looking for? We're looking for the length of this side here, side C. And remember, angles are represented with a capital letter, and across from those angles you'll see a lowercase letter representing that side. So capital C for this angle, little c for its opposite side. Big B, little b. Big A, little a. So we know we can use the law of cosines here.
Help me come to the office, please.
We know we can use the law of cosines here because we have one unknown. We can't use SOHCAHTOA because this isn't a 90-degree angle. We can't use the law of sines because to use the law of sines we would need a side measure and its opposite angle and another side measure and its opposite angle. And only one of those could be an unknown. In this case, however we would set it up, whatever way we'd set it up, we would not be able to use the law of sines because we'd have more than one unknown. We could have known over the sign of unknown equals unknown over known. That'd still be two unknowns. Either fraction you set up, either side over the sign of its opposite angle fraction that you try and set up will have an unknown. Whatever way you try and set this up, you'll have two unknowns. So the only thing we can use is the law of cosines. So what is this equation actually saying? Well, it's saying the side you're looking for, which is c squared, equals one of the other sides in the triangle squared plus the other side of the triangle squared, subtract 2 times one of the other sides of the triangle times the other side of the triangle times the cosine of the angle that's opposite to the side we're looking for. So the equation can also look like this. If we were looking for A, the equation would end up looking like this. Yep. So if we were looking for A, what changes is that A is at the beginning of the equation because that's what we're looking for. The C squared and the B squared go here, and the C and the B also go in this part of the equation. So if you look at it, the only thing that's changed is that this C and the B got replaced with a C and a B, and the A is at the beginning now because that's what we're looking for, and so the angle that's paired up with cosine also changes to there. If we were looking for side measure B, well, now we'd have A, C, A, C, cosine of the angle that's opposite to the side we're looking for. Again, the only thing that changed was this. Now the variable at the beginning is the one we're looking for. The other two variables go here squared, and those two variables show up again right here. And the angle whose cosine we're looking for is the angle that's opposite to the line that whose measurement we're trying to find. So in any case, we're only using the first form of this equation right now, and you'll be given these equations on the test. So we got our triangle, we figured out what equation we're going to use to try and solve it, so now we're going to solve it. So we just replace every variable that's in this equation with its value, and we know all of these variables except for c, which is what we're looking for. So c squared equals b squared, b is given to us. It's 3.2. A squared, a is given to us. It's 3.8. Subtract 2 times b times a. Here's b, here's a. 2 times b times a times the cosine of c. Cosine of c, and c is 45 degrees, so it's cosine 45 degrees. Now, I would have liked to have continued that in a straight line, but I'm running out of room. Let's see, you're still getting it. Yep, okay. So, now we're going to use bed mass to determine what we do first. So, bed mass, B-E-D-M-A-S. B, brackets. We're going to do what's inside, like inside this set of brackets, it's just a number. Inside this set of brackets, it's just a number. But inside this set of brackets, there's a lot of computations going on. So we're going to do that first. So everything else, everything that we're not dealing with right now, just gets written down, the same as it was in the previous step, so we can deal with it after. So now we're going to take all this in this set of brackets here and resolve it. 2 times 3.2 times 3.8 times the cosine of 45 degrees. On your calculator. That's just going to look like a big black box to you guys. But anyway, 2 times 3.2 times 3.8 times, and remember you put in the angle measure first, 45 cosine, and then equals. You should get 17.20 when you round it to the hundredths decimal place. Tenths, hundredths. 17.20. So again, it was 2 times 32 times 3.8 times 45 cosine equals. And that's what you'll get. So, bed mass, brackets. Next is exponents. We have 2 exponents. 3.2 exponent 2 just means 3.2 times itself this many times, 2 times. So it's 3.2 times 3.2. 10.24. 3.8 squared is 3.8 times 3.8. 14.44. And subtract the 17 decimal 20 from the last step. So now we've got this plus that, subtract that. So 10.24 plus 14.44, subtract 17.20 equals 7.48. So we're almost done. The last thing we got to do, we want to know the value of c, not c squared. Right now this is saying c squared equals this number. So we need to get rid of that squared sign. Well, when a squared sign, an exponent 2, moves from one side of the equation to the other, it changes into a square root sign. So now, if you can't find the square root sign on the calculators we use in class, you have to press the shift button and then this button. You'll see the yellow above this button is the square root sign, so that's the shift function of that button. So we go 7.48 shift square root of that, 2.74. So that is using the law of cosines to find the missing side measure in a triangle.